Hello students, welcome back. So as we discussed in the last class, there are two types of metal coating, anodic metal coating and cathodic metal coating. So we started with anodic metal coating. What is anodic metal coating? As I said in the previous class, we are taking the sample which has protected and we are covering a sample which is more reactive than the sample. So what happens is we are coating, if I say iron, I am coating with zinc. So zinc has lower electropotential compared to iron. So zinc undergoes corrosion and the iron which has to be safeguarded is inert and becomes cathode. So it is called anodic metal coating. So anode I am going to coat, that's why it is called as anodic metal coating, and it is also called as galvanization. So let us take an example how it is done. So here we take a iron sheet which has to be protected, and this sheet is passed to an organic solvent so that the impurities present on the iron sheet is to be removed. So that is removed when we pass to organic solvent. So all organic matters like grease, fats, etc., which is adhered on the surface will be removed when you pass this sheet to the organic solvent. Then to make it little harsh condition, we have to pass to the dilute sulfuric acid that will remove almost all inorganic substances as well as organic substances present on the sheet, and hence I can say it is cleaned and is passed through the brushes of the rollers, and then we have to pass these sheets into the tank containing molten ammonium chloride and as well as zinc chloride. So this will the purpose of passing this sheet into ammonium chloride is that it prevents oxidation of molten zinc during the process. So during the process itself the zinc will be exposed to environment. So that during the process the oxidation should not happen. Therefore we have to use this ammonium chloride as the material so that the molten zinc will not undergo oxidation. Then this sheet is passed through the molten zinc tank, where the zinc gets a coating on the surface of the iron, and it is passed to the rollers where excess amount of zinc has to be removed. So that will be removed through these rollers, and the excess zinc will be collected in a separate tank. Now we get a neat coating of zinc on the surface of the iron. Now that zinc acts as anode, and the one which is the iron which has been protected will act as a cathode. So that anode undergoes corrosion as it is applied during daily life, and cathode remains safe. That is the main objective of our use, that is iron should be safe. So this is one of the example where I can show you the large utensil has been used here. It has been coated with zinc, so that's why the silvery color appearance you get when you take out of the tank. Next is cathodic metal coating. So cathodic metal coating is one of the best method. Why? Because now we are coating a material which has to be protected with the metal which is having high electrode potential, means it is inert to atmosphere. So the below one is protected. So that method where we are going to protect the material by adding a cathode material on it, that is called cathode metal coating. It is also called as tinning. Why? Because we take tin as an example which is added on the surface of the iron, so that the tin acts as cathode and the iron acts as anode. So the cathode exposed to environment will not undergo corrosion, and the anode which is there will remain inert. So that process is called tinning. So let us have the example of that. So here we take, first we have to take the iron sheet, wash with sulfuric acid and organic solvent so that grease and the rust, whatever it is, has to be removed first, and then wash with water and dry it. Then we have to pass this into the molten zinc chloride flux, and so that it helps in the adherence of the tin properly. So zinc flux is used so that the adherence of the tin is more on that. Next we have to pass on the molten tin, and the molten tin will adhere on the surface of the iron, and then you go through the rollers so that excess tin is dropped out, and you get a sample which is coated with the tin, and that can be used for daily life. Next method is cathodic protection. So as I said, as is the second category which we have seen from the first class, that how to protect the material using cathodic protection. As the name says, here we have to make the sample whole has a cathode, means negative charge. If the whole sample is negative charge, then the one which is having positive charge will not arise. So as we know the theory, the anodic part will undergo corrosion and cathodic part remains inert. So now if the whole sample is Cathodic means there is no corrosion at all. So how to create this? So there are two types of methods. There is sacrificial anode method and impressed current method. So sacrificial anode method, how to do this? So here, as the name says, sacrificial anode. So means we are taking a sample and connecting to another sample or a metal which is more reactive than the sample. So now that active metal undergoes corrosion and that gives current to the, that is electrons to the metal which has to be protected. Hence the whole sample becomes negative charge, and the one which is acting as anode sacrifices itself to protect the cathode. So therefore it is called as sacrificial anode method. As I give example here in the figure A, you can see the tank here like petrol tank where the large petrol is stored in that, and that should be protected, and therefore it is connected to magnesium which is it is more active than the one which is sample, that is steel tank. So magnesium undergoes corrosion and giving the electrons to the steel tank, and therefore steel tank becomes whole cathode and it remains safe. Same way we have undergone pipes made up of steel, and those undergone pipes will be connected to a magnesium blocks. This magnesium blocks undergoes corrosion giving the current to the pipe, and therefore the pipe will be protected because of the cathode, that is negative charge on the surface of this pipe, and this method is called as Cathodic protection or sacrificial anode method. The next one is impressed current method. As the name says, impressed current means we are purposefully supplying current to the sample. So how we are supplying is by connecting this to a DC current, and limited amount of voltage is applied, that is the current should be applied such a way that it should be more than the corrosion current, so that it can overcome the passing of current due to the corrosion. So that current should be more than the corrosion current. If you do that, then the whole metal or the sample which has been protected becomes negative charge, and hence it can be protected. As we see in the diagram, and it requires a counter anode which has to be inert. It can be graphite or it can be platinum. So that inert is, so the circuit is complete. So inert anode is kept like graphite, and it is connected to positive terminal, and the battery negative terminal is connected to the sample which has to be protected. So hence the sample whole becomes negative charge and it doesn't undergo corrosion, and hence we can save that particular sample. Next method is corrosion inhibitors. So corrosion inhibitors, as the name says, inhibitors. These are the substances which hinder the rate of reaction, and also it prevents the metal to undergo corrosion. So we are adding purposely some reagents or substances so that the corrosion is stopped. So there are two types of corrosion inhibitors. Those are anodic inhibitors and cathodic inhibitors. As the name says, anodic inhibitors, these are the inhibitors which are added to stop the anodic reaction. That is, say example, if I have iron, the iron loses its electron to become Fe2 plus. So that is called oxidation. So we have to stop this oxidation. So if we had some substances so that we can stop this reaction, then it is called as anodic inhibitors. So the examples for these inhibitors like chromate, tungstate, molybdate, phosphate, etc. are added to the reacting medium so that the anodic reaction is stopped and iron remains as such. So if anodic reaction is stopped, then corrosion is also stopped. So this is how we are adding a substance called as anodic inhibitors to stop the anodic reaction, and hence we can prevent the corrosion of the particular metal. Next is cathodic inhibitors. Again, as the name says, cathodic inhibitors. Cathodic inhibitors means we have to add substances which stops the reaction of the cathode. So that examples like yes, before going to examples, we should know what are the types of cathodic reaction. There are two types as we discussed in the first class. One is liberation of hydrogen gas, and the second one is absorption of oxygen gas. So we have different inhibitors so that we can stop these two reactions happening on the surface of the metal. So if we want to inhibit the liberation of hydrogen gas by taking up the electron from the anodic region, we have to increase the ore voltage of the sample, so that if the ore voltage is more, then the hydrogen gas is not liberated on the surface of the sample. Hence we can stop the cathodic reaction, and hence ultimately the corrosion is inhibited. Next we are going for how oxygen is not able to adsorb on the surface. What are the reagent added so that oxygen is not adsorbed on the surface. So there are two types. that is the first one, we can see that the oxygen present in the environment is less, or we can consume all the oxygen by adding some substances. So, some examples like hydrogen, sodium sulfide are added to the environment which the corrosion happens, and the sample is that hydrogen reacts with the oxygen and liberates nitrogen. So, the oxygen is not available for the reaction now. If the oxygen is not available for the reaction, then the corrosion does not happen. So, you can see example N2H4O2, N2 is liberated and water is the byproduct, hence oxygen is removed. Same way, we have the second objective where a protective layer is formed on the surface by adding zinc sulfate or magnesium sulfate or nickel sulfate. So, I'll show you here. So, we have the zinc metal which has to be protected, and here we are adding zinc sulfate, and this zinc sulfate or the metal which has to be protected, it can be zinc or aluminum or anything. I have taken this zinc here, okay, so that the reaction environment will be more enhanced. You can take iron also. So, iron or zinc which has to be protected, you can dip in the zinc sulfate, and whatever the hydroxyl ion is present in the corrosive environment, that will react with the zinc sulfate and form a zinc hydroxide. This zinc hydroxide forms a protective layer on the metal which has been protected. Now, this metal is not exposed to environment, hence that protective layer is inhibiting the surface to be exposed to the environment, hence the corrosion is stopped. So, this is the way how we are going to protect it. Next is anodic protection, the last topic of the discussion. Anodic protection here is similar to the impressed current method we saw in the cathodic, where we are making the whole metal as anode and hence prohibiting the reaction. So, here if we are making this whole anode, the reaction happens to a certain level and that leads to a passive layer, means an inert layer is caused on the surface of the metal, and this passive layer will not allow the corrosion to happen, hence this is protected, the sample is protected. So, example here is we can take example of storage tanks, reactors, etc., and some heat exchangers where we purposefully apply the current, and that metal undergoes corrosion and forms a thin layer on the thin layer of its and it forms a thin layer of oxide layer, and that is a passive layer. That passive layer will not expose to the environment, hence inhibiting the corrosion. Then, thank you.